What's going on, you guys? Welcome back to the channel. In today's video, we are going to completely recreate the core functionality from the classic app Jetpack Joyride in Python using the PyGame module. We're going to do it completely from scratch in under 2 hours, barely 250 lines of code. So Jetpack Joyride was the runner-up for my 5,000 subscriber video. It was either Donkey Kong and Jetpack or Jetpack Joyride. And Donkey Kong won. Obviously, we made that for 5,000 subscribers. That was still awesome. If you haven't seen it, go check it out. But basically, Jetpack Joyride received a lot of votes too. It didn't beat out Donkey Kong, but a lot of you were interested in seeing kind of that core functionality built out. And what I thought would be an interesting way of doing this one is basically doing the entire thing using PyGame's native drawing tools. So for Pac-Man and for Donkey Kong and a lot of the platformer, a lot of the bigger projects I've done, I pulled in a lot of images from like outside games. And for this one, I wanted to do the entire thing inside of PyGame and show you don't need a bunch of fancy images to have a fun game to play. So this is entirely in PyGame using PyGame's native drawing tools. Okay, and some of the highlights just to show you is we're actually animating the player with this like 4-step sequence when they're walking on the ground. We have progressively more difficult game speed, so it gets harder as you go faster. Hopefully you've seen that as I play here. The background color changes screen every 500 meters just for a little bit of like random fun variance. And then also something that I haven't shown yet is a working pause menu complete with tracking the lifetime distance that you've run, as well as the option to restart, quit out of the entire project, and this sort of semi-transparent layer over the screen to just show that you're paused. So there's a lot of really cool stuff here. It doesn't take super long relative to some of my biggest PyGame projects. It's only about an hour and a half of real coding. And so I hope you guys find this fun. This was a lot of work to put together. A huge thank you to everybody who leaves a lot of nice comments and likes on the videos. It has been great for channel growth. I wouldn't be here without the super supportive community that is always watching these videos. And of course, a special big thank you to my Patreon supporters, Dale Topley and Philip Nunez. I really appreciate you guys, and your support goes above and beyond. So without any further ado, let's get right into the tutorial. All right, let's get into this tutorial. It is a long one, so I'm going to dive right into it. But as always, any questions that come up through any part of the process, just drop them in the comments. I will get back to you as soon as I can. Make sure to start by importing the random module and PyGame. Most full games that you're building, you're going to want to put some aspect of RNG in there. So importing the random module is important. Importing the PyGame module, obviously, and then pygame.init, because that is the framework that we're going to build our game on. Now for this one, I'm not going to make it too like dynamically resizable like we did with Donkey Kong, because I want to keep this a little bit shorter. Some of those videos get up to like 4 hours, almost 5 hours. We're going to try to do a little better than that on this one. Okay, so then we're going to set up our screen using this permanent width and height that we define, and I'm going to make it 1000 by 600, so hopefully even people with smaller laptop screens can run the full thing. And then I'm going to do screen equals pygame.display.set mode. And then we're going to use that width and that height variable we just defined. And one more thing that I'm going to do here is I'm going to define a surface. And people who keep up to speed with the channel and saw last week's video know that we did a tutorial on how to do a pause menu, which is something I want to put into this game. And to do that, it's this setup pygame.S surface, and then it takes a few arguments. It takes size, just like pygame.display.set mode did for the screen. And so we give it width and height, but then we give it this additional argument, src alpha, which is going to allow us to draw things onto this surface with a transparency setting. So that'll be really useful for a pause menu where we kind of put a mask over the entire screen. Okay, so moving on, let's go ahead and set the caption for this one. This is kind of an optional step, but I like to do it. Pygame.display.setCaption, and this one will say Jetpack Joyride Remake in Python, just like that. Okay, so that is the caption. Now let's go ahead and set up an FPS of 60. So that's the frame rate we want our game to run at. And we'll set up a timer as PyGame.time.C clock like that. And let's go ahead and set up a font because I know we're going to want some text in this game as PyGame.font.F font. And then free sans bold.ttf. I use this a lot because it's included in almost every install of Python, and so you don't need to import a font file to use that. But if you have a specific font you want to use, just point to that file here. Okay, so now let's go ahead and start building out what I always call the main game loop. A lot of you probably saw that coming because I've set up a lot of main game loops with you before on the channel. But basically, we take this variable run, set it equal to true, and then we say while run. And the first thing we're going to do is basically timer.tick at our frame rate. And then we sort of want to start thinking about how the game is going to play. But even before we do that, we can just do like a screen.fill with black just for proof of concept so we can boot this thing up. Because ultimately, we will be drawing everything onto the screen in a function that we'll call drawScreen. But for now, let's just make it a black screen so that we have a functioning code. And let's set up some event handling. And so we'll say for event in pygame.event.get, just like this. And we'll say if event.type is equal to pygame.quit, all caps like that. That is a special type of Pygame event. And that is referring to the red X in the top right corner of the window when you boot it up. Okay, and so if we press pygame.quit, let's go ahead and set run equal to false. And then down here, just pygame.display.flip, and then pygame.quit. And so this should be, unless I'm forgetting something, which happens sometimes, this should be all we need to just get our window on the screen. Yep. Okay, so Jetpack Joyride remake in Python there at the top and just a black background. And if I click an X here, then it just goes ahead and it exits out of that window. So that is great. Let's go ahead and instead of this screen.fill black, let's go ahead and make a function that we'll call drawScreen. And we're going to need to pass some things into it and get some things out of it before everything is done. But for now, let's just go ahead and set up this function. And to do that, we're going to call it in the main game loop here by saying drawScreen like that. And then we have to come up here and do define drawScreen like this, okay? And now up here, we're going to start putting the things onto the screen. And you probably saw in the intro of the video, or if you've played Jetpack Joyride, basically the player doesn't actually change their X position. The entire screen appears to be sliding to the left from the right as it goes by. So we need to think about that while we build this game. Now I'm going to move that screen.fill black into this drawScreen function, because I deleted it in the outside world. It's just good practice, everything visual we're doing to put onto the screen, okay? So now let's go ahead and let's draw some stuff onto the screen. So we'll do pygame.draw.rect, and I'm thinking for like the overall background, it would actually be really cool to have like a changing background color every 1,000 points or something. So I'm going to draw that onto the surface, and I'm just going to make something new like background color. So BG color here. And to start, I'm just going to make it a gray. Okay, I'm going to make it 128, 128, 128. But now I'm going to draw this rectangle onto the screen, and I'm going to use that BG color. Yeah, I'll just use BG color, but this is kind of tricky. I want to make it semi-transparent, so I actually have to put it in a tuple like this, and I'm going to have to add all three of those variables and then a 50 or an alpha argument. So it might seem a little bit silly. I'm going to do this because it's more direct than using like the unpack star. But you could do that as well. I talked about that in past videos. But basically, this is going to draw a somewhat transparent mask of color onto our black background. And so that'll give us kind of a cool, not just constantly having a boring black window. While I was playtesting it, that's actually something I added pretty late in the project. And then make it start in the top left corner 0, 0, and then make it the full width and height of your window. So this is a rectangle that we can change that background color as we play. And it's going to kind of make it visually more interesting. And then we're going to do this screen.blit that surface onto the screen at 0, 0. So this is an important step. Again, familiar to anyone who watched the pause menu thing, but we've created a surface that can handle alpha arguments, semi-invisible arguments, and so we have to draw that onto the screen as well. And now let's go ahead and make two rectangles. Let's make a top and a bottom rectangle, and we'll call just the top equal to PyGame.draw.rect, and this we can put right on the screen. We want it to be solid, and we'll make this just a regular gray, okay? You guys feel free to play with any of the style that you want to change at the end, but basically I'm using some just default stuff so we can get the game going, but you certainly can make it a little bit more visually intriguing if you want. And then the top rectangle is going to be in the top corner, so 0, 0, the full width of the screen, and then just 50 pixels high. And then the bottom rectangle, rather than being 0, 0, will be 0 and then height minus 50. Okay, so 50 pixels up from the bottom, still full width, and then still 50 pixels high. And then what we want to do is we need to create some lines that are going to sort of slide from the right to the left. So we're going to have some line list, and we're going to draw them all on the screen. So we'll say for I in range the length of this line list. And I'm kind of waving my hand at the name line list for a second. We'll make that in just a second. But let's go ahead and say we're going to pygame.draw.line. And then on the screen, we're going to make these black lines that will have position. So for a line, you just give it 2 points. And it'll be line list 0, or line list, I guess, I, because all we really have to keep track of for the line is the X coordinate, and the Y coordinate will kind of be fixed 50 pixels. And then let's go ahead and say this line underscore list will just really be a list of X positions. And so it'll go from 0 to 50, and we'll make it 3 wide. And that's going to be a top line that'll be showing up on the top black background. And then we'll do one that'll be on the bottom now. Oop, caps lock was on. So height, oh, come on. Okay, height. I keep turning caps lock off and it keeps going back on. All right, height minus 50 down to height for this second line, and we'll still have it be 3 pixels wide. And I think what we probably need to do is I probably need to create this line list for you guys so that you can picture this. So let's make a list for our lines. And the first X position I want is just going to be 0. The second one will be width over 4. The second one will be 2 times the width divided by 4. And this third one will be 3 times width divided by 4. So what I'm doing here is I'm creating 4 lines X positions just so that when we make let's actually do that at the same time. When we make this game speed that the whole board is moving at, I'll make it 2 initially. We'll play with that later. But basically, I'm making these lines that we need to have move across the screen at whatever game speed we have to give the illusion of motion, because we, the player, are just staying in the same X coordinate. So everything has to slide past us to look like it is moving backwards, which means we need to pass those lines into draw screen, and that will be the line list that we're receiving in here. But now what's interesting is because these are getting drawn in here, I also think it makes sense to make sure that they're moving in here. And so let's go ahead and say, if not pause. So I'm going to get a little preemptive here and say I know I want to put pause functionality into this game. When I boot it up, I'll say it's initially false. But if it's not paused, then I want the game to appear that it's moving. If it is paused, don't update these. But let's basically say line list at I, because all line list is a list of X positions, right? We'll do minus equals game speed. So that's going to move it to the left by whatever speed the game is moving at. And then let's just go ahead and say if line list of I is less than, and we'll say -3, then what we want to do is just line list at I equal to width. So remember, those are 3 wide. Actually, let's go ahead and make it 0, and let's just take a look at what that does, okay? Reformat, missing white space. Okay, so if we did this right, this little bit of code here is actually pretty nifty. It's going to create an infinite loop of lines moving across the top of the screen that will look like the game is constantly just running by us. But what we have to do is, because we're editing the line list, is we also have to return the line list. Okay, so that's pretty important. Now let's go ahead and run it. And yeah, you can see we just have these black lines that are resetting themselves every time they clear off to the left, that tell us we are moving in that direction, right? And if you were to speed up game speed, make it 12, I don't know, you can see like it's still pretty clear that we're moving during the game. So this is a really cool bit of drawing the background, drawing the screen. I think we could go ahead and draw the player if you wanted to at this point, just so we can kind of see them on the screen. We are certainly going to be coming back to draw screen, because when we get the laser, we're going to be drawing the laser onto the screen. And when we're checking for collision, we're going to be using those top and bottom rectangles. So preemptively, let's just pass top and bottom back out of this function, and we'll come down to where we call it in the main game loop, and we'll just get the top and bottom platform here as well. All right, so we are getting lines back, and then we are also getting a top platform and a bottom platform that we will be using later. Okay, but so now we are getting all of those updated values from our draw screen function, and that seems like a good time to go ahead and set up the draw player function. So we're going to get the player's hitbox out of this function. So I'll just make something called player, and we will get that back from draw player. Okay, so let's go ahead and just minimize draw screen for now. This is basically all the code to move lines across screen and draw BG images. All right, now we need to draw player including animated states. All right, so the player, obviously, as you guys probably saw in the intro, the player has a rocket pack that only shows up when the player is actively boosting the rocket upwards. And then the player also, when they're on the ground, their legs are going to move in kind of like a 4-sequence animated run. And we're going to do it completely in Python, or in PyGame, which I think is pretty cool. So bear with me, there's a lot of drawing PyGame objects here, and I think it'll be kind of cool to see. You'll sort of get a good vibe for what we're drawing, because I'll keep kind of showing it each time we draw a shape. Okay, but the important thing to remember is we're returning the player's hitbox here. So let's go ahead and say player equals pygame.rect. So I don't actually want to draw this one. I just want to define a rectangle for my player's hitbox. And a good X position I found was about 120. In Jetpack Joyride, I downloaded it on my phone just to verify. I think you're actually a little closer to the middle of the screen, so like maybe 300 would be better. But I kind of like this. It gives you a little more time to react. And then we are going to have this player Y function, because that's actually the only direction the player moves in. And let's go ahead and say that initially the player Y will just be equal to height minus 130. Okay, so that's the size I'm about to make the player. That's pretty much equivalent to starting on the ground. And actually, one thing even better is, I think let's call that value initial Y. And then let's set the player Y equal to that initial Y. But this way, when we do like restart code, we can set the player's Y position back to the initial Y. So storing that in a variable will kind of come in handy later. But now we're going to use that value to draw a whole bunch of different objects. And so if you're coding along line by line with me, these sizes are all things I got from kind of playtesting and drawing my very specific object. So I'm going to keep moving pretty fast through this, but feel free to ask questions if you're not sure what any of it is doing. So for the player's hitbox, I'm going to make it 25 wide, 60 high, and I'm actually going to scooch it down from the top of the player a little bit just so we get more realistic collision, okay? And now let's go ahead and handle what to draw and when, because basically all the time the body of the player is going to be in the same spot. So that would be like pygame.draw.rect screen. Let's go ahead and make the jetpack, which is just a rounded rectangle. And this is going to be a little bit to the left of that player hitbox that we just defined. And then it'll be at player Y plus 20, so a little bit down from the player's hitbox, and then 20 wide and 30 tall. And this is going to be something that we make solid, but a rounded rectangle with size 5, okay? And now let's go ahead and draw the player's main body, pygame.draw.ellipse. So an ellipse is a shape that basically takes a rectangular argument because it sort of fills in the space that a rectangle would take, but it's an oval basically. Okay, and we'll put this on the screen. I liked orange for this game. It's not something I've used a whole lot, and so I kind of enjoyed making this game orange. And so that'll be 120, which is the start of the player's hitbox, and then player Y plus 20 because we're going to put a head on top of this body, and then 20 wide and 30 50 tall for this one. So 20 wide, 50 tall. And then this doesn't take any more arguments than that. All right, so this is going to look a little bit rudimentary, but what you should see is basically player. Oh, I just called this player. It's draw player. All right, what we should see is a white jetpack riding on the back of an orange oval. All right, and that's exactly what we get. Obviously, the player can't fly yet because we haven't put controls in for that. But you can kind of see this is like a body and that's like a jetpack. Feel free to play around with the sizes. I'll do this. Pygame.draw.rect screen. Let's make this green. And I'm going to draw the player rectangle on the screen for a little bit so that you can see the hitbox. All right. So now you can see this thick green hitbox that I defined. That's going to be what we use for player collision. Okay, so let's keep going. We need a few more circles now because I want to draw a head with an eye on it. And I'm actually realizing now I made the player 30 wide. So let's do that. And now pygame.draw.circle. We'll put it on the screen. We'll make this orange as well. The head will be the same color as the body. And now for a circle, the only thing you need is a center point and a radius. So the center point will make 135, so it's pretty close to the middle of the player's body that we just created. And we'll move it so that it's a little bit above the body, which is where the head typically is found. And now let's just draw one more circle. Let's make it a eye. So this will be a black circle that we will draw on top of the head. So 138, player Y plus 122, or plus 12, not 122. And then we'll just make this radius of 3. So that should give us a head and an eye effect. Let's boot that up. Yep. Okay, so you can see now kind of why I picked the hitbox that I did. It's a little bit under the top of the head, and it won't catch like the bottom of the feet, which I think is kind of perfect because it's really annoying to play a game and have an oversized hitbox. I'd rather have a slightly undersized hitbox. Kind of the same thing we did with Mario for Donkey Kong. Okay, but so these were jetpack, body, and head. And those are always going to get drawn regardless of whether we're in the air or not. What we have to do now is we have to start taking a look at drawing the objects that are only going to be up sometimes, so conditionally. So what we'll say is if player Y is less than height minus 130, or you'll remember we stored that in a variable init Y. So what we're trying to check here is the player in the air? Because if the player is in the air, it doesn't make sense to do the like running motion with the legs because you're stationary. So the way Jetpack Joyride looks is while you're in the air, you're not running. That kind of makes sense, right? So what we'll do is we'll say if the player is in the air, our y coordinate is less than what it's equal to being on the ground, or the game is paused, because I don't want the legs to keep running while the game is paused. Then what we'll do is we'll say, okay, a variable we haven't made yet, if booster. This will be what we use to detect if the player is actively telling the game to sort of move upwards, use the rocket, or if we're falling back to ground. But if booster, then we want to draw like flames under the rocket, okay? So that's going to be pygame.draw.ellipse, and we're going to do 3 ellipses now. We're going to do like an overall body and then a little detail in the flame, because like a classic cartoon flame has like red, yellow, and orange in it. And so that we're able to see this while we draw it, I'm going to make that variable booster, and for now I'm just going to set equal to true. Ultimately, that'll be getting set in our event handling once we get there. But for now, let's just set it equal to true so that we can see what we're drawing as we draw it. All right, so I'm going to draw this onto the screen, and I'm going to make the kind of outline of the whole thing red. And then the rectangle, I guess this is going to occupy, is going to be just below the jetpack that we made. So it'll be at an X position of 100, and then player Y plus 50, and then it'll be 20 wide and 30 tall. Okay, so this is going to be something that we're going to want to copy and just modify for the next 2. So I'm going to do kind of an orange lick of flame and then just a splash of yellow over top of it. So these are going to go red, orange, and then yellow on my layers. And I'm going to scoot them progressively a little bit further to the right. They'll all start at player Y plus 50, but then they'll get a little bit narrower. So 10 and 5 for the width and 30 for the height for all of them will work pretty well. So what you'll see now is when I boot this up, you'll see nothing because the player's Y is less than the init Y. So I have to make this equals. Okay, let's try that. Okay, so now you can see this cool like red, orange, and yellow, and that'll go away and come back only when we're telling the player to continue flying. So that's like a really neat little animation. Now, obviously when the game boots up, you're not going to be holding space down. So we'll just set it equal to false initially, and let's move on, okay? So the other thing we want to do is if we're in the air, we want to draw legs, but they're just going to be kind of dangling because we're in the air using a jetpack. So to do that, we'll do a few rounded rectangles. And we'll do this 2-tiered thing so that we kind of look like we have a yellow back leg and then an orange front leg. It's going to be kind of a cool way of giving us a 2-tiered effect. We'll put it at X position of 128 and then Y position of player Y plus 60. We will make the legs 10 wide and 20 tall. And then I want it to be a solid rectangle but rounded with 3 radius on the corners. And then I'm going to do one more leg. It's going to look very similar, so I recommend copying the previous line and just 2 pixels to the right, so 130, and then everything else can stay the same. And now what you'll see is we get so the flames have gone, but on your computer it should be real clear too. We have this yellow back leg and then this orange front leg, and we'll use that for when we are on the ground for running. So I'm going to do a couple things now. I'm going to just comment out the hitbox. I think I've shown why it's the shape that it is, and we don't need to draw it on the screen. I'm also going to get rid of the less than or equals to on this because when we are booting it up, we are on the ground. So I think what we should do now is we should take a look at drawing the animated legs during the running motion. And this is the other piece, like those lines sliding to the left and then the legs animated looking like they're running is kind of the other really cool piece to making this look like we are moving, even though our X coordinate is not changing. Okay, so like I said, I want to make this kind of 4 tiers, like a 4-panel animation, which is going to be like inside leg back, legs back to middle, inside leg forward, legs back to middle. So we need these kind of 4 panels. So what we'll do is we'll say if counter, so some value that we haven't made yet is less than 10, then we'll basically draw position 1. And then we'll say elif 10 counter to 20. So we'll do if the counter is greater than or equal to 10, but then less than 20, just to keep it consistent. And then we'll say in here, draw position 2. And then we'll say elif one more time, and we'll say 20 less than or equal to counter less than 30. And then draw pause 3. And then we can do an else, because there should always be something getting drawn. So we'll say draw pause 4. And basically position 2 and position 4 are going to look exactly the same pretty much. But the position 1 and position 3, rather than drawing rectangles, we're going to have to draw lines, because pygame.draw.line, because it's a lot easier to draw a thick line than draw a rectangle and try to rotate it. So we're going to do pygame.draw.line, put it on the screen. And remember, we have two legs. We have an orange leg and a yellow leg. So we'll draw the orange leg, and we will say, put that at position 128, player y plus 60. That should look familiar, because that is where we basically hinged the, and actually we'll say for the orange leg, 130. That's basically where we told them to be when we're not running. So when they're in the middle, we want them like that. Excuse me, I don't know why I have so much phlegm in my throat. Okay, but pygame.draw.line, that's going to be our starting position. And then where we want it to go to is going to be back a little bit. So we'll have the orange leg going back a little to player y plus 80 now. So it's still 20 high, and then it'll be a 10 thickness leg, okay? So now we'll do our yellow leg, which we are pivoting about 128. And actually, does it make sense to do orange then yellow? I think we should do yellow then orange, because we've kind of set this precedent that the orange leg is on top. Okay, so let's go ahead and do that. But then everything else can stay the same, with the exception of going up to 140, I think is what we want. So we'll go from 128 to 140. Yeah, we'll see. I think that's going to look good. And then we'll copy these two lines for position 3. And now the only thing is we're going to switch this to 120 now, 120. And we're going to switch this up to 140. So basically, yellow leg forward, orange leg back, both in the middle. Yellow leg back, orange leg forward, both in the middle. And for the both in the middle, we can just copy these two real nice from the bottom of our, if we're in the air, because they look like the legs in the middle. And so now, if you're an astute observer, you're going to see a bunch of red lines on my counter variable, because we have not set up any counter code. But we have done literally everything else we need for an animated player. So let's go ahead and take a look at what we need to do to set up the counter code. And obviously we are going to go ahead and initialize the counter variable. It'll be at 0 when we boot the game up. Hopefully that makes sense. Now let's go ahead and say right under our timer.tick at FPS, we will say if the counter is less than 40. Right? That's kind of what we just defined, is we want, and feel free to play with these times. These values are not sacrosanct. You can change them up if you want. But basically, we will add one to the counter every scan, so that's 60 times per second. If we haven't hit 40, then we will just add 1 to it. But if we have hit 40, then we will set counter back equal to 0. And that should be all we have to do to have an animated running player's legs. So, okay, maybe it's just because I'm a nerd, but I think this is super fun already. Like, you have this player running along on the bottom of the screen. I think it looks really cool. Now, for us to properly see the jetpack working and the motion, we have to put that booster kind of control into the active event handling. So let's go ahead and do that next. I think that would be fun. So we need to add a new event type, and we will do key down if event dot type is equal to pygame dot and then all caps key down. And let's go ahead and say that if it's not pause, then we want to be able to do the booster. So we'll say if event.key is equal to PyGame dot k space, there we go, and not pause, okay? Because if we're paused, you can't change the player's elevation. But what we'll say is when you are not paused and you press the space button, then booster is equal to true. Okay, so booster is that variable that we made in the drawing the player animation. Let's just go ahead and reuse it. And let's copy all of that code to key up. And let's just go ahead and say if the key that was just lifted is space. And for this one, I don't really care if we're paused or not, because it will just be setting booster equal to false, which is fine. It's really fine if booster stays false, because we're not going to be changing the y velocity when booster is false. So let's come down underneath our event handling now. So make sure, I've made this mistake so many times, don't you make it as well. Make sure you're outside of your game handling. So you're at the same indentation level as that for event in pygame.event.get, because it's very normal for me to start writing code right here. And it doesn't run except when there's new events, which is not what we want for this. But now let's go ahead and say if not pause. So again, this is just double checking that we don't want to move our player's Y position when we are paused. But what we'll basically say is, okay, if booster is true, so that booster variable, then my Y velocity should change. And because 0 in the Y direction is actually at the top of the screen, we'll say it should be minus equals, and we'll say that we can go up, we can go up with the same speed that gravity will drag us down. So we'll say else Y velocity, it's not going to be here because we haven't made it yet. So Y velocity plus equals gravity. All right, so the thing is, unless you are on the ground, which will handle checking for collision with the ground in a function, unless you are on the ground, you're always either going up because you're using the rocket, or you're falling back down because you're not using the rocket. And so that is all we need to do really to handle X position. What we're going to need to do next is just figure out what to do when we are colliding, okay? So let's go ahead and make those Y velocity and gravity variables just so that we can test this. Excuse me. And we'll just say when the game boots up that our Y velocity is equal to 0. And gravity is kind of a fun one. You can play with this some if you want. I use 0.4. It seems to be pretty good for the game mechanics. But basically that'll change how quickly you fall, but also how quickly you can change directions. So that's something that you can modify to have a good responsive game for yourself. But now let's go ahead and boot this up. It's going to be a little tricky in the beginning because I'm going to have to start controlling almost immediately. No, I'm not, because it's not doing anything. Why aren't you doing anything? Oh, do I have pause equals true? Let's check that. No, pause is false. Okay. Oh, right. We're not doing anything with Y velocity yet. Doy. Okay, so then what we'll do, still assuming we're not paused, is player Y plus equals Y velocity, okay? And so that's gonna do it for actually moving the player's position. It'll be a little hard to test because I think, yeah, all right, there we go. But all right, look at that. So we've got basically, if I go below the floor, you can see the walking animation comes back. And then when I'm giving the booster, our flames that we draw show back up. So I think that's really, really cool. Obviously, it'll make our lives a lot easier if we get the top and bottom floor collision working. So let's go ahead and do that, because what I need to do is I need to add something in here to reset Y velocity to 0. And basically what that's going to look like is if colliding with the top, so or I'm sorry, if I'm like colliding with the bottom platform. So there's going to be two different collisions. There's going to be colliding with the top and colliding with the bottom. And basically, if I'm colliding, and you have to think this gets a little tricky, I know, but when y velocity is negative, we're actually moving upwards. I know that's kind of difficult to grasp unless you've done a lot of PyGame games, but 0 is at the top of the screen. So as we subtract from our y position, we have a negative velocity. And so if our negative velocity and we're colliding with the ceiling, then we need to set y velocity equal to 0 because now you've collided and you're not moving anymore. But if y velocity is positive, so y velocity is greater than 0, then we are colliding with the bottom. So these are the two conditions, and I promise we're about to go and set them up. But basically, we'll make colliding 1 equal to colliding to the top, and that would be you have a positive velocity. And if you are colliding with the bottom and you have if you're colliding with the bottom with a positive velocity, we need to stop you. And if you're colliding with the top with a negative velocity, we need to stop you. But we don't want you getting stuck on the ground or stuck to the ceiling, which would happen basically if you release the booster or if you start using the booster, if we don't add in those and velocity checks. So hopefully this will make a little bit more sense once we do the colliding. But those are the two conditions where we need y velocity to be equal to 0. Okay, so I think I have officially confused everybody enough. Let's go ahead and make our colliding, there we go, our colliding equal to a new function that we will call check colliding. I try to do a lot of functionality in separate functions. It's a little bit more object oriented and it's a little bit easier for debugging. So there will be some stuff that I just throw in the bottom of the game loop because it doesn't feel to me like it merits its own function. If you disagree, throw it in its own function. I won't fight you on that. Okay. Now let's go ahead and make the check colliding function. And let's assume when we boot this up that they're false and we have to see that the player collides with the top and the bottom for it to be true. Okay. And now let's just make sure that we return the colliding list that we make. And let's go ahead and see here. If the player, so we've already made that, so that makes our lives pretty easy, collides with the bottom platform, which we've also already made, and we can use PyGame's built-in collide rect function to check if the player is colliding with the bottom rectangle. Then we'll set 0. Remember, we said colliding at index 0 would be equal to standing essentially on the bottom platform. But then we'll say if player.collide rect with top plat, and really this can be an elif because we're never going to be colliding, hopefully, with the top and with the bottom. So we'll say elif player.collide rect with top plat, then we'll set call 1 equal to true. And that's it. That's all we have to do to check if the player is colliding with the top or the bottom. Now we will add some stuff in here to check if the player is colliding with the laser obstacles and if the player is colliding with the rocket, because we're going to put in lasers and rockets. But for now, that should be enough to check if we are standing on the ground or flying into the ceiling. So let's go ahead and boot that up. And you can see now the player is just standing there. And I can fly up to the top, but I can fly into the top. And then as soon as I let go, he goes back to the ground, lands on the ground, starts running again, lands on the ground, starts running again. Anytime I fly, the flame comes back, which looks really cool. So overall, I think we have player movement and player animation looking really good. So it's probably basically time to incorporate either distance and progressive difficulty or lasers and rockets and obstacles, and we have to do both. So let's just go ahead and do lasers next. This is going to get a little bit weird, but also just super cool. So I hope this I hope this project is hitting with other people who played these games on their phones and never gave a second thought to I wonder how that's made, or I wonder if I could make that. And now it's yes, you can make it. Absolutely. And you should. It's super fun. Okay, so let's make some new variables. Let's make a variable when it's time to make a new laser obstacle, and I'll spawn one when the game boots up. So I'll set it equal to true initially. Let's keep track of the laser's start and end points because they could be vertical or horizontal. So we'll put those in a list, which initially will be an empty list. And let's use those two to generate the laser, and then we'll also draw the laser onto the screen. But first, let's just go ahead and say, if new laser, then let's generate a laser. Okay, so let's come down under our counter code, and let's just say, if it's time for a new laser, then we'll set our laser, which is that list variable we made, equal to generate laser. So this is a new function that we have to make. So let's come here and say define generate laser. Freaking sharks with freaking laser beams. And we're going to use that in draw screen in just a second. But for now, let's just make sure we don't forget to say that, okay, then new laser is equal to false as well. We only want to generate one at a time. So let's come into our generate laser function, and let's just say that 0 will be a horizontal laser and 1 will be a vertical laser, but we'll let it kind of be random. We imported that random module. It'd be fun to make it a little bit random. So we'll say the laser type will be either 0 or 1, random rand int between 0 and 1. And then the offset, we'll make this random too. So how far to the right off screen do we want it to spawn? It could be anywhere from 10, which is just off screen to the right, all the way up to 300, we'll say. And now, just because I think a lot of people use these as educational resources too, and not just for fun, let's do something, instead of saying if laser type is equal to 0, let's use a match case. So this is just, we're basically saying we want to match on the value laser type, which is either going to be 0 or 1 in the case of either 0 or 1. So I did a video recently on how to use match case. It's really good for basically something where you would use an if else, but you're just checking multiple values of one numerical value. You're checking 4 multiple values and doing something different for one numerical value. So you could say if laser type equals 0 and then else. That would be fine, especially because we have 2 values here, but the code we're about to set up will be useful even if you had like 20 different types of lasers you wanted to draw, which is feasible. I mean, depending how many features you want to add to this after I'm kind of done with you, you might want to add more on here, and this will be really easy. But so I'll say, okay, however long it is, basically for a horizontal laser, we'll make that random between 100 and 300. And then the Y position, so it's horizontal, so we only need 1 Y, but let's make that a little random too. And let's say it could be anywhere from 100, so 50 pixels off the top, to height minus 100, which will be 100 pixels off the bottom. So it could spawn anywhere in there. And this new laser that we've just created, keep that underneath here too. That new laser is going to be equal to, and now square brackets, because it's easier to do it in square brackets than a tuple, because we're going to want to update it as we move the whole screen to the left like we did with those lines. You cannot update individual elements in a tuple. You would have to take each element out and basically modify them and then stick them back in as a tuple. It just makes it easier if you store it as a list. So what we'll do is we'll say, okay, the new laser's starting position is going to be the width of the screen plus whatever that offset we came up with was. And then its Y position will be laser Y. That'll be where it starts. And then where it ends will be width plus the offset plus and the laser width variable that we just came up with. And then the Y position will still be laser Y. So this is going to put a start and end coordinate in the new laser position for a horizontal one. Now we're going to copy these 3 lines because it's fairly similar to do a vertical. And what we'll do is we'll say, rather than laser width, we'll call this laser height. And let's say that for the height of this, it can be between 100 and 300. So same size lasers as the horizontals. And now for the laser Y, where it starts off, I think for this one, we're actually going to want to be a little bit more careful, because if we had a 300 pixel long Y, or a 300 pixel tall, we wouldn't, if we want a gap, Let me make sure I'm thinking through this right. Yeah, if we want a gap on the bottom of 50 walkable pixels, then we have to say that this could never go higher up than height minus 400, because that way if we did end up with a 300 tall laser, we would still have a gap of 50 on the bottom. You can play with these. Again, there's no hard and fast rules about the values that I'm using. Yeah, okay, so anyways, that was a long way of saying do what you want, but this is what I'm doing. Okay, and now let's go ahead and say that the width plus offset can stay the same as starting position, and then laser Y can stay the same, and then width plus offset stays the same for X position. We get rid of the plus laser width, and now we can say plus laser height for Y. So basically this little function will, all right, now last thing, return the new laser. Oh my goodness, I am just trying to type and talk and it's not working well. And then return new laser like that. So basically this function is going to get us a new laser when it's time for a new laser, but where we actually draw it onto the screen will be the draw screen function, obviously. So let's go ahead and pass it in, and then we want to get it back too, because we're going to be moving it in the draw screen function, so it'll be best to pass it in and then also get it back. So let's go back into the draw screen function, and again, try not to use the same name on the inside as you do on the outside, so I'll just call it lays here, and we'll pass it back. Alrighty, and let's go ahead and say that we are going to use that laser to draw a line on the screen, and so let's make this line which we will use for collision, because remember, if the player collides with the laser, it's game over. So let's store that in laser line, and let's pass the laser line back as well. But basically the parameters for this line are going to be pygame.draw.line. All right, and then we need to say, put it on the screen. Jetpack Joyride laser obstacles are all yellow, so we will make this yellow as well. But again, that's a style thing you can change up if you want. And then the coordinates, it's really nice because of the way we generated them. We can say that the starting X coordinate is laser 0, 0, and then it goes to laser 0, 1, and then laser 1, 0, 1, 0 to laser 1. And I'm saying laser, but obviously the variable is lays. Please don't argue with me over this. Okay, and now one more argument. Let's just say make it width 10, okay? And that's going to give us the laser line on the screen, which is pretty cool. But the other thing I want to do is I want to come down into the if not pause, where we move the line list to the left by game speed, and I also want to move the laser X coordinates to the left minus game speed, so minus equals game speed. I'm not sure why I started the second one, but we already have this nice loop that says when it's not paused, let's move all of our vertical lines to the left, so let's also move our laser X coordinates to the left. And actually this is 1, 0, not 0, 1. That would have looked funny. You would have had a laser moving in two directions. Okay, so let's just add that so that it's sliding to the left on the screen as well. And now this is a stylistic preference thing, but the Jetpack Joyride lasers have these like balls on the end that are like holding the laser, which kind of makes game sense, but it also just kind of looks cool. So really quickly, what I want to do is I want to draw kind of those end caps on the screen as two yellow circles. So I'll say pygame.draw.circle, screen, yellow, and then center point for them will just be the points that we cooked up with our laser line. So the center for the first one will be the center points of our laser line at position 0. And I'm going to make it radius 12. I thought it looked good. Feel free to play around with it. I don't think I have to keep saying that. And the second one will be the same thing, just 1, 0, and 1, 1 instead. And now that should be everything we need to draw the laser onto the screen and then move it to the left as the game is played. And so the only thing that we have to do is we have to make sure that we are generating. Oh, also I passed the laser line back, but I didn't say that I was receiving it yet. So let's receive the laser line out here. Now, the only thing is we haven't looked at when to generate a new laser. And so this is one of those things, it's not really worth doing in its own function in my mind. I'm going to come down below the if not pause, and I'm just going to say if laser 0, 0 is off the screen and laser 1, 0 is off the screen. So basically the laser has moved all the way to the left, and it is off the screen, so it is less than 0. Then spawn a new laser will be equal to true. Okay, so this is just going to basically overwrite the previous laser that has moved all the way off the screen. It's so simple, I think it's justified putting it down here at the bottom. If you feel differently, put it in a function. I don't know what to tell you. All right, let's boot that up. We haven't checked for collision. Oh, right, I made game speed 12. That's excessive. I'm going to put game speed back to 3 just while we're testing so we can look at this. Okay, and you have these pretty good sized lasers. All 3 have been horizontal, so if there's a vertical one, in pretty good. Oh, I would have died there. In pretty good positions, moving left across the screen, and I think they look really cool. So I'm actually super satisfied with that functionality. What I think we need to remember is that we need to check for a collision with the lasers in our check colliding function. But I don't want to do that yet because I'm not quite ready to put in restarting code. What I think I'd like to do now is I think I'd actually like to go ahead and take a look at some of the scoring. Okay, so basically tracking total distance that we've gone. So initially your distance is going to be equal to 0 in the very beginning. And we already have this game speed, right? We have this game speed going on down here that sort of handles how fast we're going. Let's say that game speed directly relates to meters. I mean, you could pick whatever unit you want, but basically the long of it and the short of it is that we should add the we should add the game speed to this distance variable every iteration that we're not paused. So let's come into our if not pause down below the game logic, and let's just say distance plus equals game speed. Okay, so basically now we're going to have a running total of how far we've traveled, and in Jetpack Joyride, that is how the scoring works. Okay, so let's go ahead and now let's add in some progressive speed increases, because that's how the game gets harder. It starts moving a lot faster. So basically what I found is that it's fun to sort of speed it up every 100 meters or every 500 meters, but you don't want to go by whole numbers. So what we'll do is we'll say if distance is less than 50,000, okay? Because if you get to 50,000, you are going to be flying with the speed parameters that I built. So we will cap the speed out there. But until you get to 50,000, we'll say that the game speed is equal to 1 plus, and now the distance that you've traveled rounded down to the nearest integer of 500, but then divided by 10. So this means that every 500 meters you travel, your speed will increase by 0.1. That's what this divided by 10 is doing. And then what I'll say is else, so you're at or above 50,000, game speed caps at 11. And if you don't believe me, set game speed to 11. You are not going to want to go any faster than that. If you are surviving at game speed 11, you have amazing reflexes, and you can just see how far your score gets you, okay? So that is all I'm going to do on the progressive difficulty for now. And what I think we should do is we should display the distance that you've traveled onto the screen. We already have the draw screen function. So let's just come up here and let's add essentially two pieces of text. Let's add some scoring for the current distance, and then just getting a little bit ahead of ourselves, taking a peek at future functionality, we'll also add some high score text. So let's go ahead and say font.render. I'm going to do screen.blit and font.render in the same row. You could break them out, but it's really easy to define the text here and just say that as a formatted string, the distance will be, and I like to define, make sure that it's an integer here, because when you do math, like divide it by 500 and then divide it by 10, Python can convert it to a float because it's doing math with it. So it makes it easier on us if we just say display it as an integer, and then I'll say meters. I'll put an M on it. Then say anti-alias is true. I'm going to make this text white, but you are welcome to make it any color you want. And I'm going to put it in the top left corner. And so this is just going to be some distance tracking text here, okay? And now what I'm going to do is I'm going to put high score, and then I'm going to say int of high score, which doesn't exist yet, so we got to go make that. And for now, just for testing, I guess, I'll put it just below the high score. So I'll put it like at 1070. And now I have to make high score real quick. High score equal to 0, I guess, when we boot up. We will save to an external text file and read it in from an external text file. So it will actually track things like that. Okay, now let's just put some really simple high score code in here, which is if distance greater than high score is equal to distance. Okay, that's sort of the simplest possible way. I guess, again, distance is having math done with it, so I'll specify I want that to be an integer, a whole value of distance. But okay, so we are drawing hopefully distance and high score onto the screen. I am sure it's possible I made some mistakes there, so let's boot it up and take a look. Okay, yeah, so we're actually getting, and you can see they're changing together, which is fine, and I can fly through the lines currently, which is cool. But yeah, so my distance is going up, my high score is going up, and what's kind of cool, you'll see pretty clearly if I just leave them here, is that it is getting faster. Every 500 meters that we travel, it's getting slightly faster. I did verify this as well. I won't leave it on this screen for too long, but if you guys have followed along up to this point, you can time it if you want. Every 1,000 is faster than the 1,000 before it. And you really start to notice it around like 3,000, maybe 5,000, but it's an enjoyable level of added difficulty. Okay, so that is enough for now for drawing the screen, I think. We should probably put in some code for how to restart. That will make a lot of this a little bit more meaningful, a little bit more interesting. So let's go ahead and make a new variable that I guess we'll just call restart. Yeah, that's a good name for it. We'll say restart underscore CMD, and it'll be equal to false initially. But I want to put in essentially collision detection with the laser now, because that should go into check colliding. And I want to set restart equal to true if you collide with the laser. So let's come in here and let's make an RSTRT. So this is our restart in here. That's initially false as well. And then I'll say if the laser line, remember that's what we called the actual line of the active laser, dot collide rect with the player. So that is the player's hitbox. And if that is true, then we'll make restart equal to true as well. And then we will pass that back out of this game. So we'll say that colliding and restart command come from, come from the check colliding function. And that's enough for now. Once we put in the rocket, because that's the other obstacle in Jetpack Joyride, we'll also reset the game on restart as well if necessary. But let's come down, because there's a few different things that could make you restart. So let's just come down near the bottom of our function and take a look if any of those things tell us restart command. Then what we want to do is we want to set our distance equal to 0. We want to set pause equal to false. So if you have paused the game already, we want to basically resume it. Player Y set back to that initial Y. So that there's where kind of having that in a variable is useful. We'll set the Y velocity back equal to 0. We'll reset the restart command to 0. And we'll say we do need a new laser. So we'll say true. There's also some stuff we're going to do for the rocket when we get in here. And there's also some writing to the text file that we're going to do when we get into it. But for now, let's just see if I can run into this laser and have that reset the game. Okay, bang, it did. And you can see the high score held on, but the distance changed. And it goes back to the beginning. We get a new laser. Our speed changes. We're back on the ground. So that basic restart functionality seems to be working really well. I think the next most fun thing, the way to keep you guys engaged, is let's go ahead and build in the rocket code. Okay, so basically what I want to do is I want to come up by my counters here, and I want to say, yeah, I guess we'll go right under this new laser equals false after the draw screen function. And we'll say, if we don't have a rocket active, so there's going to be a few variables we have to make once we sort of talk through this. But if we don't have an active rocket and we haven't paused the game, then I'll make this new counter, so rocket counter plus equal to 1. And that'll be checking how long it's been since we had an active rocket. But then what I'll say is, okay, if the rocket counter, if rocket underscore counter has gotten above 180, which at 60 frames per second would mean about 3 seconds. And if you feel like you're getting too many rockets or not enough, feel free to play with this value because this 180 will change how often they come. What I'll do is I'll set the rocket counter back equal to 0, but I'm going to take that rocket active, come on, there we go, and set that equal to true. And then what I want to do is, if you actually remember Jetpack Joyride, there's like an exclamation mark on the right side of the screen for a little bit that warns you of where the rocket's about to come in, and then it launches. And so we'll have this thing called rocket delay that will reset equal to 0. And then initially, I'll have these rocket coords, and when I first make it, it'll sort of be off screen with the coordinates of width and then height over 2. And now what I'll do is I'll say if rocket active, then I'm going to have to do sort of two different things. I'm either going to draw an exclamation mark saying, hey, a rocket is coming, or draw the rocket on the screen. And to do that, we're going to use the if rocket delay less than 90. And actually, I just want to not forget about any of these. We have rocket active, rocket counter, rocket delay, and then rocket coords. Let's just go ahead and make all these variables real quick. So rocket variables real quick so we don't forget about them. And we'll say, yeah, the counter is equal to 0 initially. There's not initially an active rocket. Delay 0, and coords, it doesn't really matter. Empty list should be fine. Okay, but now I've instantiated all those, initialized all those values. All right, now what we say is if the rocket delay is less than 90, and again, play around with this. If you want the exclamation mark to be warning you for a little bit longer, make it bigger. If you want the exclamation mark to go away faster, make that smaller. But so basically, if we're not paused, then let's add 1 to the rocket delay. So rocket delay plus 1. And then the rocket coords, as well as the actual shape of the rocket, will be what we get back from our function we're about to make, draw rocket. And in there, we just pass in the rocket coords. And now I'm going to pass in a 0 saying that I'm in mode 0 because I want to use the same function to actually draw the rocket. So if the rocket delay is greater than 90, what I'm going to do is I'm going to pass in the same thing. I'm going to get rocket coords back and the rocket, but I'm going to just change this mode to a 1 basically. And now what I'll do is I'll say if rocket coords 0, so its x coordinate, has gone off the screen by 50 pixels. So I'm not exactly sure how wide I'm about to make the rocket, but 50 pixels off screen should make it all the way off screen. And that is what I will do to reset rocket underscore active. Okay. Now, the only thing we have to do is draw our, so I'll copy this whole line just to make sure we don't forget anything. Let's come up under generate laser and let's say define, and I'm going to get rid of these guys for a second and return. And now inside the function, I will just call this coords and I will just call this rock. And what I will do is I will pass in coords and mode. I will, rather than just having that be a 0, I will say that is mode. And let's go ahead and take a look at what we can do with the coordinates we were given, as well as the mode that we are actively in. So what we can do is we can say if mode is equal to 0, I need to draw a warning. So we'll say that basically the rocket rectangle is equal to pygame.draw.rect, put it on the screen, and let's make it a dark red warning rectangle at position coords 0 minus 60. So this is going to get it on the right edge of the screen, and then coords 1 minus 25. So it'll be 50-50, and that's just going to be a good looking rectangle on the right of the screen. Solid, but we'll make it a rounded rectangle, and that'll be the warning rectangle. And we will do screen.blit of some font as well, because I think in Jetpack Joyride there's an exclamation mark on the warnings. So we will put an exclamation mark on that block. Anti-alias true. Let's go ahead and make the text black. And then the position we want to put that on is just basically on the block that we just defined. So coords 0 minus 40, and then coords 1 minus 20. And those will be, that's just basically a warning rectangle and a warning rectangle with an exclamation mark on it. And now, if we're not paused, what we do is the rocket actually kind of tracks the player. So if you've seen Jetpack Joyride, the exclamation mark shows up, and then it kind of goes up and down on your screen, depending on how it needs to move to track the player. So we'll say if coords 1 is greater than player y plus 10. So sort of a good target, because player y is the very top of the player's head. So if the rocket will just track a little bit down from that. Then what we want to do is we want to change the y coordinate by 3. And then we'll say else, let's go ahead and change the y coordinate by 3 in the opposite direction. So this is just going to make the warning off screen track the player. All right, but then what we can do is we can say, all right, if mode's not 0, mode must be 1. Now the rocket is going to shift to actually being a projectile. So pygame.draw.rect, put it on the screen. This time, let's just make it red, bright red. And then the coordinates for this will be coords 0, coords 1, minus 10. So basically just scooting it up a little bit, but using our actual x coordinate. Let's make it 50 wide and 20 tall. So it's more tubular, more like a rocket. Solid, but still rounded rectangle of 5. And now the body of the rocket is moving across the screen. So what I think we should do is pygame.draw.ellipse. Let's put a little flame behind it. Less elaborate than what we did under the player's jetpack, but still just kind of cool to indicate like it's a rocket. And we'll put it at coords 0 plus 50, and then coords 1 minus 10. So very similar to what we just did for the tube, except to the right of it, because it's a flame that is pushing it to the right. And then I'll make it thickness 7. You'll see in a second, it just kind of looks cool. And we'll say if not pause. So once the rocket has been launched in Jetpack Joyride, it no longer changes in the y direction. We can leave coords 1 alone. but we want to subtract it at a speed that I'll say 10, and then add in the game speed. So eventually the rockets will be coming at you very quickly, but they'll always be going at least 11 because they're rockets, so they go pretty quick. All right, so that should be everything we need to draw and actually update the positions of the rockets. Let's go ahead and boot that up. We're not handling collision with the rockets yet, so I don't really have to dodge them, but hopefully we can see what they look like. Okay, so yeah, there's a warning, which I think looks really cool. And then, okay, the rocket comes at you across the screen, which I think looks really cool as well. So I guess probably what we should do is we should add rocket collision. You can see they keep coming and they look pretty good. So let's go ahead and just go into our check colliding function, and this should be the last thing we have to add to check colliding. So after if laser line, what I'll do is I'll say if rocket is active, because we only want to check this if there's a rocket. Then we'll say if rocket dot collide rect with the player, then we will set our STRT equal to true there as well. So remember, we're assuming we don't need to restart, but if I collide with a laser or a rocket, I do have to restart. Okay, so core functionality is kind of built out. What I think would be really good now is if we took a look at how to, I guess we can test getting hit by a rocket real quick, just because it's fun to get shot with rockets. All right, come on, hit me. I want you to do it. Okay, so that was interesting. You probably saw the rocket got to continue finishing off screen. So we just need to come down into our restart command, and we need to add in that rocket active goes to false, and the rocket counter, if it was active, should go back to 0. That should be enough for now. So let's take a look at adding pause. If you watch all of the videos on the channel, of which there's only like 5 of you guys, and I appreciate every one of you, but we have already done how to implement a pause menu. And fortunately, it's really easy. We just come into our key down code, and we're gonna add whatever key we want to initiate pause. So I will say if event.key is equal to pygame.k escape. That is what I use for pause menus. What we'll do then is we'll say, okay, if I pressed escape and I was already paused, I'll use that to resume. But then I'll say, okay, otherwise, I will use that to activate pause. So that is all we have to do there. And is now the escape key can make pause happen. So let's just go ahead and boot that up and see. All right, I press escape, distance stops counting and everything stops moving. And so actually just pause functionality is working really well. But I don't just want to be able to pause the game. I want to show that we're paused. So let's go ahead and make a function that I will call draw pause. And there will be some buttons on it because it's a pause menu. So there's things that you can do on there. So now I'll come down here and I'll say if pause, then draw pause. And now I want the ability to restart and to quit so I'll say quits just because quit is like a built-in Python word. So I'll call it quits, but those are my 2 buttons that I want to get out of the draw pause function. So let's just come in here and let's define draw pause. And let's not forget to return basically restart and quit button. Okay, so those are the 2 things. I'll just say restart button. I don't know why I had to be fancy. Restart button and quit button. And let's take a look at everything we want to draw onto the pause screen. So let's go ahead and pygame.draw.rect a semi-transparent mask. So I've talked about this a few times. 128, 128, 128, and 150 for transparency. And I'll put that at 0, 0, width, and height. So a full screen size, somewhat transparent gray mask over the top of whatever was already being drawn. Okay? And now let's put some stuff on the menu. So pygame.draw.rect, let's put it back on the surface. Now I want a dark gray rectangle And for this one, this was sort of just arbitrary, like me designing a pause menu. But I made it 600 wide, 50 tall, and I put text explaining that you are on the pause menu on this. So then the next thing I did was basically surface.blit some font, some text, font.render that said game paused, escape button resumes. So basically it's just telling you like, oh, you got here by pressing the escape button will resume for you. You do have to put that in quotes. I don't know why I didn't. And then anti-alias true, color black. And yeah, I just think that looked pretty good. And then positionally, so put it at X 220 and then Y 160, put it nicely in that rectangle that we made. Okay, now the next two things are the restart button and the quit button. So restart button was equal to pygame.draw.rect, and I made the two buttons clickable. I made them white just to differentiate. Put them all on surface here. And I made it a white button, and then X coordinate of 200, Y coordinate of 220, so it's below that text we just made, and then 280 wide, 50 tall was a good button size, and then solid but rounded with rounded edges of 10, and then golly, I am just clicking all over the place today. Okay, and then after the restart button, I made the quit button. There we go, and basically it's the same button just scooted way to the right, so 520, because this was 200. 520. This was 200 and 280 wide, so that puts it at 480, and then a nice 40 pixel gap. And now I'm going to copy this surface.blit font.render. We're going to have to update the space, the size, the position. There we go. But we can sort of use that format. So for this one, 220 is still good, but it needs to move down to 230. And now that we have that, our quit text, quit, or you could call it exit, whatever you want, will be at that 230. That part can stay, but now it needs to move down to 40x, X position. Okay. And I think something that we'll do in just a second is we'll add onto here like a lifetime distance tracker, which would be cool. But we're not going to do that until we look at how to save data to the text file and extract it. So the last thing we're going to do for now, screen.blit our entire surface that we just drew onto here into position 0, 0. All right, now we're not doing anything with those buttons yet, but we are drawing a pause screen. So let's go ahead and run this and see if it all looks okay. All right, I'm running, I'm in the air, I pause, game paused, escape button resumes. I can click at the buttons, but they don't do anything yet. And then I can hit escape again and it comes back. Okay, so that's pretty cool. That was not particularly hard, but now let's take a look at, we have this restart and this quits. And we need to add some functionality. So this is going to be a new section, which is going to be mouse button down because we're trying to click on buttons. So we'll say if event.type is equal to pygame dot and then mouse button down. And you could even add something here that says and pause because we don't have any buttons anytime except the pause menu. And we'll just say if restart, is that what I called it? Restart? Yeah, restart and then quits. If restart dot collide point with the event dot pause. So if the button that we just defined, the rectangle, collides with the position of our mouse click, well, we can just take that restart command that we already have and set it equal to true. And then it's pretty easy to say if quits dot collide point with event dot pause. So if I said that I want to quit, then I can just take this variable run, which is the main game loop, and set equal to false. It'll be as if you clicked the red X in the top of the screen. And now let's just go ahead and test that. So let's test both buttons. I'm flying, I'm in the air, I'm at 150, here comes a rocket, and I pause. Okay, I restart. Everything looks good. It saved my high score. and my distance reset and everything, and I can pause. Now let's go ahead and quit, and it closes the program. So I would say that menu is working really good. What I want to do next is take a look at how to modify the player info by saving it to a text file and reading it from a text file. But one thing that we didn't do that I said very early on I was going to do, and it just kind of makes it a little bit more fun to play, is I want to track how far it's been since I changed the color, and I want to change the background color based on that. So I'm going to use a variable called new background just as an integer value to keep track of how long it's been since I changed the background color. And I'm going to come down under my new laser code, and I'm just going to say if distance minus new background is greater than, and I'll do every 1,000, I'll do every 500 when the speed changes as well. All I'm going to do is say new background is now equal to distance. So I'm keeping track of whatever distance I'd traveled once I changed the background color. And I'm just going to change the background color to a completely random color. So random.randint from 0 to 255. If you remember, we make it somewhat transparent, so we don't have to worry about ever getting the exact same orange as the player and then we're invisible. Because we have that alpha value on the background color, it will never be exactly the same as the player, even if the R, G, and B are the same, because it has a different alpha. But let's just boot that up real quick, and I'll make sure I can survive at least 500 here. So if that's working right, then we're going to hit 500 and get a totally random new background. And yeah, hopefully you can see it change to kind of a darkish green. Let's see if we get a more fun one when we hit 1,000. And back to a gray. All right, let's get one more just because I'd like kind of a nice color for once. All right, purple. That's cool enough. But you can see it's kind of it's a fun way of really feeling like you're progressing through levels. I did something similar for the background on Doodle Jump, and people seem to enjoy that. So, okay, enough jibber jabber. Let's jibber jabber. That's awesome. That's a fun word. Let's go ahead and make sure that we have a way of modifying the player's info. So what I recommend doing now is making a playerinfo.txt text file and putting it in the same project folder as your project that you're building. And I'm just going to start by putting 2 rows of zeros in it. So there's going to be your all-time high score and then your total distance traveled. So those are the 2 things I'm going to put in playerinfo.text. And what I want to do is up here, so still outside the loops and everything, I want to load in player info in beginning, okay? And this is not hard. It doesn't take a long time. What we're going to do is we're just going to say file equals open, and then our file name, I called mine playerinfo.txt, and then I'm going to specify that I want to read from it right now. So that's all I want to do is read equals file.read lines. Read lines. There we go. And that's going to get me all I need to know. And I will say that high score is equal to the integer value of what I got on the top line. And I kind of know that this is going to work because I just made the file to start out with 0, 0. And then my lifetime is going to be the second row. So an integer conversion of read 1. Because remember, you read it all in as text. And then I'm going to do file.close to sort of seal the file after I get the information that I need. And now I don't have to define high score here. And I have this new variable lifetime, which is how far I've traveled over the entire course of the life of the player. But there are a whole bunch of times we want to modify the player info. And so actually what I think makes the most sense is we make a modify player info function because we are going to want to be able to adjust the high score and the lifetime distance traveled if you exit out of the game, if you have to restart, if you pause and press the restart button, if you hit a rocket, anything like that. So anytime you restart, we want to modify the player info and before you exit out of the game. So what we'll do is Here, it's generally considered bad practice to call a bunch of globals in a function, but the only two things we're modifying are high score and your lifetime distance traveled. So I'm going to give you a pass for using global here. Hopefully you can give me a pass as well. And now let's just say if distance greater than high score, then what we need to do is we need to say high score equal to distance. This is kind of like what we do at the bottom of every loop. So you can view those two lines kind of as optional. But what we're going to do is we're going to say lifetime plus equals distance. And then file equals open, same file name, playerinfo.txt, but this time we want to write to it. And then we're going to do file.write two things. First, we're going to make a string conversion of the integer value of our high score. Okay, so I know it's a little weird to do string on integer, but I don't want to write a string version of a float. And then what I'm going to do is I'm just going to add this new line character. So plus \n to make sure that that ends that line. And then file.write string int and then lifetime. So anytime I update this, I need the high score on the top row and then the lifetime distance traveled on the second row. And then I can do file.close. Okay, so, and I don't really care that it shadows the name from the outside scope. So the only thing that I have to do now is I have to make sure that I call this at all the critical times. So basically, first thing I'll do in restart command is I will modify player info. So before we clear out all of those values, I want to call that function just once. And then it will basically clear out those values. Now, the other thing I want to do is I want to say if I press the quit button, so go back into the event handling and say before run is equal to false, I want to modify the player info. And actually, I'm going to do that if the quit button is pressed as well. So if you press the red X in the top, we still want to capture, like say you hit the red X and you've traveled 2,000 or 5,000, we should still capture that in your lifetime run amounts. So I believe those are the only two places, I guess 3 places, that we need to add it for now. And if we look at our total lines of code, we have 268, which is how many my notes say we should have. So let's boot this up and play it real quick. Let's see what we got. Okay, it's tracking my distance and my high score. There are missiles coming after me. There's lasers that I need to dodge. I think the player kind of looks pretty cool, considering that we drew it entirely within PyGame and their native tools. There's obviously, like, you can import images and you get this more polished game look, but there's something about, like, as a programmer, just knowing that you generated 100% of the objects on the screen using like native drawing tools, I think is kind of neat. It is fun to see how like basic objects can stack on top of each other and create like more intriguing visual shapes. And as we play through this, you see the backgrounds changing every 500. Hopefully you can feel as you play your version. It is speeding up every 500 as well, which is adding some complexity, a little bit of challenge. And yeah, I think this is like super compelling. It's really fun. It's got a lot of the features of kind of the classic Jetpack Joyride, but obviously like a very home-baked sort of flair to it. Okay, now I've got 6,400. I've kind of been stalling by talking so that I had a high enough score that when I hit escape and I hit restart, and now, okay, my high score is held, my distance is changing, but now I've got like 450, 500. Okay, so I'm going to hit quit. I've got 500 currently and a high score of 7,300. So my total should be like 7860-ish when I hit quit. I'm going to go into that playerinfo.txt and you'll see I've got 7862 and the 7345, which was my high score. So the only other thing I want to do that I think is very compelling is I want to add to the pause menu just a quick little display of how far you've run in all of your games. So basically, what I want to do is I want to take this dark gray screen, square and text that we did for the like instructions, like game paused, whatever. I want to make that kind of same rectangle, but I want to move it down some. So 200, 300, 650, 0, 10. And then instead of game paused, escape button resumes, I want to say lifetime distance ran. Just like this. And then I'm going to put these curly brackets and make this an F string. And I just want to show integer, whatever the lifetime accomplishment is. And this is just a fun way. So move it down to 310. This is a fun way of when you hit pause now, you're going to get to see how far you've run over the course of the game. It's just a really cool added feature. And now let's go ahead and run this. Okay, hopefully it loads in. You can see it preserved the high score from before, which is awesome. And I hit escape, and it has my total distance of all the games that I've finished, which is awesome. So I'll just resume. I'll run to like 500. I'll collide with this laser. Bang, I died, okay? And my lifetime distance ran updated. So restart works, quit works, the X out button works, pausing and resuming works. We can dodge obstacles. We have somewhat randomly generated lasers and rockets. We have progressive difficulty. We have this fun homegrown animated player. I had so much fun making this. I stopped here because honestly, I started looking at all the different features that I could stick in here. Like I could put a layer of images over top of it. I could add some form of like missions that you have to accomplish these different missions. But what I really felt was the core of the game is built out in here now. And so I, welcome you to take the code from the GitHub and add features onto it, make it your own. Certainly let me know. I love seeing all the forks and branches on GitHub. I love seeing everybody who's started. So I know a lot of people find these projects fun and helpful and code along and add on, and that is so great. I appreciate everybody who sticks with me through these longer videos. I know they are not the easiest thing in the world to stick with. I know YouTube says the optimal video is like 10 minutes long, and I'm regularly rolling out like multiple hours worth of content. But holy cow, you guys, this was fun. This could be the last huge PyGame project for a while, as I am getting ready to welcome a child into the world. So if this is the last big PyGame project for a little while, let me know in the comments below what you think should be the next one when we do come back and I have a little bit more time and life gets a little less crazy. Thank you so much, everyone who stuck it out. Thank you all for watching. Thank you for all the subscribers, all the likes on all of the videos. Good luck with your code. Good luck with, I'm just rambling now. Good luck with all your projects. Thanks for watching. Until next time, bye.